Hi there, welcome back to Histo with Ale. Today we're going to talk about the different types of simple aqueous fixatives and their function, properties, and more. I'm going to give a brief explanation from each one of them and give some advantages and disadvantages. This is going to be a two-part video, so I'm going to start with acetic acid. Acetic acid, commonly known from vinegar, it is a fast-penetrating chemical often used in fixatives. When highly concentrated, it is called glacial acetic acid. In my experience, I have seen histotechs adding glacial acetic acid to eosine working solution to enhance a cleaner and more vibrant pink to the cell. Acetic acid preserves nucleoproteins, especially nuclei. It is often added to fixative mixtures to enhance nuclear detail and to counteract tissue shrinkage. But it causes significant tissue swelling and leaves tissue soft. Red blood cells are easily destroyed. It is classified as a non-coagulant fixative, and it does not fix lipids or carbohydrates. Remember to always add acid to water, not the other way around, to avoid dangerous reactions. Formaldehyde is the most widely used fixative in laboratories today. Later on, I might need to dedicate an entire video to it. But for now, here is a brief introduction. Formaldehyde is a colorless gas commonly supplied in labs as a 37% to 40% solution in water, known as formalin. When we refer to 10% formalin, we are actually talking about a 10% dilution of that stock solution, 1 part formalin and 9 parts of water, which results in a final formaldehyde concentration of approximately 3.7% to 4%. Older terms like formol or formal may appear in historical texts, but they are rarely used today. Formaldehyde works as both an additive and non-coagulant fixative. It forms cross links between proteins, especially targeting amino groups, which stabilizes tissue structure. It alters proteins binding, making tissue more basophilic, which takes up more hematoxylin. Lipids are preserved but not made insoluble, so they are lost during routine processing. Unless frozen sections are used, it penetrates quickly, but actually fixation is slow. May take up to 48 hours for complete fixation. Formaldehyde is widely used in histology. It causes minimal tissue shrinkage. It is compatible with most special stains. It is relatively cheap and stable. And today diagnostic standards are based on formalin-fixed tissues. But formaldehyde can form formalin pigment called black acid hematin in acidic conditions, especially in bloody tissues. This pigment may interfere with some stains but can be removed with alcoholic picric acid or alkaline alcohol. To avoid pigment, keep pH around neutral, 7.0, and use proper volume. And last but not least, formaldehyde is classified as a carcinogen. Glutaraldehyde is a dialdehyde which makes it similar to formaldehyde in how it cross-links proteins, but the second aldehyde group often stays unbound. This free group can interfere with staining methods like PAS, causing false positives. So these stains should not be used on glutaraldehyde fixed tissues. Glutaraldehyde is commonly used in electron microscopy because it best preserves fine structural details, but fixes tissue as it penetrates and does it so poorly and slowly that is not good because tissue samples must be thin to ensure proper fixation. It can overharden tissue, so fixation should be limited to no more than 2 hours. After that, the tissue should be transferred to a buffer solution to prevent damage until further processing. To end, always remember all chemicals mentioned in this video must be handled with great care and respect. Follow your lab safety protocols and comply with OSHA and other regulatory guidelines to ensure a safe working environment. Safety first, always. And for more information and explanation, be sure to refer to the Frida Carson textbook. And if you're following along, do not forget to like, comment, and subscribe so you do not miss the next episode. Thank you.